GCSE Physics Boosters. This video is about power. Now, in the electricity topic, I've done another video about power, but that's mainly to do with electrical power, and there are some equations for electrical power that you need to know. Power is current times voltage, power is I squared R. Worry about them in that topic. This is more about mechanical power, although strictly speaking it's the same thing, it applies to both. Anyway, this video is about power. Let's get on with it. Now, these are three kettles. They are water heaters. And what do? They transfer energy. They transfer electrical energy into heat energy. That is their job. That is the energy transfer. But what's the difference between them? Well, look at the numbers underneath. The first kettle is like in a caravan or in a cheap hotel, and it says 150 W. W is watts. It's 150 watts. The one in the middle is probably something like you've got in your kitchen. That's 2 kilowatts or 2000 watts. And then the last one, you'd probably find that in a canteen. That's 5 kilowatts or 5000 watts. So the one on the right is more powerful. It has a bigger power. Now, so what? What does that mean? What does power mean? Well, power is the rate of energy transfer, or it's the rate at which work is done. In physics, loads of times we say the rate of something. The rate of something means divided by time. It means per second. So the rate of energy transfer is the amount of energy transferred per second. So it's energy divided by time. Or the rate at which work is done, the amount of work done divided by time. So that means that we could measure power in joules per second. Power could be measured in joules per second, and if you did, it wouldn't be wrong. But it does have its own units, which is watts, capital W. Now, don't get the W for watts muddled up with the W for work. In fact, for energy and work, just use capital E because it's energy. Okay, watts for power is capital W. Named after this Scottish bloke, James Watt. He was a Scottish inventor and he made steam engines, some of the very first steam engines. Let's do a little question now. It takes 4,200 joules to raise the temperature of 1 kilogram of water by 1 degree centigrade, because that's the specific heat capacity of water. Now, how long would it take a 2 kilowatt kettle to boil 1 kilogram of water, which starts off at 20 degrees centigrade? So work out the amount of energy first, and then work out the time. And I'll show you the answer. Have a go yourself. I'll show you the answer in 3, 2, 1. There you go. So we rearrange the equation because we want to work out time. And so time is energy over power, and you should get 168 seconds. Here's another question which you must be able to do. Here are two winches which are driven by electric motors. One of them is 1.3 kilowatts and the other one is 2.2 kilowatts. So the second one is more powerful. Okay, every second it does more work. Okay, it's more powerful. How long would it take for each of them to do 30,000 joules of work? Well, you have a go. Pen, paper, calculator, and I'll show you the answer in 3, 2, 1. There you go. So again, you need to rearrange the equation. By the way, you need to learn that equation. Rearrange it. Time is energy over power. So the first one, 23 seconds. And then the second electric motor, it's more powerful. It does it quicker. It does it in 14 seconds.